The analogy I'm using here is that the old story of the seven blind men and the elephant. You know, one of them goes up and says it's like a wall. One of them says it's like a tree. One of them says it's like a rope, etc. So this is just seven different ways of thinking about the instrument. See if I can work this. Okay, I'm not going to talk in detail about any of them. So this is sort of like a plate of appetizers. So you sort of pick, and hopefully anyone who's interested in the particular areas, I'd urge you to go deeper. One of the things that I found in preparing for this talk was there's a lot of things about the history of the instrument that I didn't know. For example, I'd never read Bob's 1964 AES paper before, and it's really interesting to see what he was saying. And then some of the references, what people were talking about even in the 1950s, that sound like they're talking about current technology, although they were talking about a very, very different world in those days. So these are the seven. The circuits, the engineering is kind of amazing for the 1960s. We'll see a little bit about that. The construction of that instrument down there, it's unbelievable. We'll talk a little bit more about that too. It was made in America. We'll talk about, I'm also talking about just the short supply chain. I started thinking about this during the supply chain crisis, and his supply chain was not interfered with by a lot of the problems you have now. It was a failure as a business. The modular synthesizer, when Bob Moog built it, did not actually succeed very well. And I think I'll probably go more quickly through these because I think this is sort of the theme of everyone else's. It's both a historical musical instrument. This is a specific thing that was used at a certain time. And as Diego is talking, I think it's still relevant today, even at this very moment. And finally, it is a joy to use. Anyone who's had a chance to spend time with it, it's really wonderful, and the people as well. So some of the circuits are standard to this day. You can still buy, there's many synthesizers out there that have the filters, the oscillators, the mixer, and maybe I should do, I have one quibble. I apologize also, here's my fourth apology to Tomer. I'm not sure I fully understood what you were saying. But when you said that there was no wave folder in the Moog, that's not quite true, because the CP3 mixer actually, when you overload it, it does act as a wave folder. And if you put a sine wave into the CP3 and then you turn up the gain, it will push it into a square wave. And there's a lot of people who attribute a lot of the sound. It's usually associated with the filters. Everybody says, oh, the Moog filter, the filter, but the CP3 actually adds a sweetener. It's not as dramatic an effect, and it's not called a wave folder, it's just called the CP3 mixer. So it's almost invisible in that way, but from a technical, electronic and musical point of view, it is acting as a wave folder. The exponential converter, very simple, just noticing that you could use a transistor to, it's volt per octave, so which makes an easier mapping. I think Korg used volts per hertz, but volt per octave became the standard. The ADSR, there's a great story. I'm not sure, I have a memory of hearing Herb Deutsch tell me this story, well, not me personally, it was a group of people, but I may have just read it in a book, so excuse me for that. But the story goes that Bob and Herb were talking, and Bob said, well, just tell me a little bit about, I want to, sort of shape the overall, envelope of a sound. Tell me what sort of that looks like. And Herb was like, well, there's an attack phase, like a horn comes in slowly and a violin comes in more quickly, and then it sort of decays off the peak, and then there's a sustained element, and then eventually when you stop producing the sound, it releases. And so then Bob put in the attack, the decay, the sustain, and the release. And Herb, at this point, he said, if I had known this was going to become the standard for all synthesizers, I would have thought a little bit more about it rather than just rushing out and saying, oh, this is what it is. Because here we are more than 50 years later, and you can still buy ADSR envelope generators for your synthesizer. Now there's some ADDSR with variable wave shapes in between, but we've made some progress in the last 5 decades, but not a lot. One of the other things, and this was just, I don't know, are there any electrical engineers in this group? Any people with an engineering background? Okay, well, I won't, oh, there's, okay. So there's no op amps used in any of these designs. These just have transistors, and they're built from transistors. You can see sort of like certain aspects of op amp-ishness, if I can use that phrase, in terms of the way that they process the sound. You see these differential pairs of transistors that have a sort of a hint that Bob was thinking along the same lines. And in later ones, I didn't include this, but in some of his later instruments, he did use op amps. Okay, so this very simple, right, diagram is the famous filter, the one in the instrument downstairs. Is this the laser? Can I? So, first of all, you see here, this is the back panel. I'll talk a little bit more about this. These things aren't just patched on the front. They also have a bunch of connections in the back where inputs come in. This is the input mixer, sorry, for the control voltages. This is the input for the audio signal. These matched pairs of transistors here are the ladder as it goes through. This is what actually does the filtering. And just because I have to brag a little bit, this is the capacitor that didn't work, which is why it wasn't resonating, and so it had to be replaced. This right here. And I thought that was a 25, but it's actually a 2.5. You have to zoom in to see that, so it took me 2 tries to get that. I didn't actually put in 2, I figured it out before that. But if you count this, I think there's less than 20 transistors in this entire thing. And it's kind of amazing to me that he was able to achieve this like landmark sound, which I don't have it on my presentation because I just recorded it today, but as I was walking out of my hotel right in Zion Square, there were kids jumping up and down, and you could hear the womp, womp, womp. You know, you can hear, it's really the soundtrack of Jerusalem in some ways. This is the oscillator. This is a 901B. This is the second half of the oscillator. Again, here the diagram's a little harder to understand because, can I take this out? So I can look, and so this again is the connection to the backplane. Let me see if I can remember here. Oh, here's something that's sort of interesting. These are the different capacitors that set the range. This is what's called a relaxation oscillator. It slowly charges and then discharges a capacitor. And each of the different capacitors, the higher the capacitance, the more energy it can store. And the more energy it can store, the longer the time constant is. And the longer the time constant, the lower the frequency. And the circuit, because it's a very simple circuit, is only linear over a very short range. And so what Bob did is, rather than a modern synthesizer, you can do a better circuit that would be linear over say 5 octaves, and you wouldn't need to do it this way. But this way, if any of you were down and heard the instrument being demonstrated, you could hear the click as the ranges were being switched, and that's this switch right here. It's a little hard to read these, but these are different capacitors that all have different values that come in. And again, this thing has something like 10 transistors in it, which is not a lot. But it did have certain deficits. It doesn't have really great temperature stability. So if you're doing experimental music, maybe you don't care, or if you like that sort of warmth, or if you don't mind retuning it a lot, if you listen to Wendy talk about her experiences with the Moog, she's spent a lot of time retuning it, because to play the kind of music that she was playing, it had to be in tune and had to be consistent across the entire recording and over all the different layers that she was doing. And she spent a lot of time wrestling with the fact that even though Bob in his 1964 paper talks about, oh, well, I have this and the temperature compensation is that, it didn't really work that well. But given the limited amount of electron components, it's really impressive. By comparison, this is an early op-amp. This is the 741, the first really huge commercially successful op-amp. And this has over 20 transistors just in it. And for those of you who are not the 1EE who's in the room, an op-amp is just a basic fundamental thing. It's used like a transistor is used in circuit design now. It's the symbol of it's just a little triangle, and you put it everywhere. And it performs a lot of purposes. But as I said, in these early ones, Bob didn't have those. They weren't really available yet. And he couldn't use them. So it is built like a tank. This is actually a still. I didn't put it up. I took some footage of me repairing it, but I had the camera. You can see my fingers, and I think you can hear me cursing occasionally because I was trying to get these. This is the circuit board, and it has this frame around it. You can't really quite see it, but it's screwed into the front panel with these screws. And then you had to remove those, and then I had to undo some of these. it was a nightmare to get this thing apart. Once I got it apart, pulling out the capacitor was simple. If you've ever looked at a commercially available, I think Tamara, you mentioned Eurorack. Most Eurorack modules are done in a very different way. Here you can see that the circuit board is perpendicular to the front panel, and so you have to actually screw on the sockets and the potentiometers to the front panel. On a Eurorack, it's parallel. It's much smaller, and the same hardware that secures the potentiometers and the sockets to the front panel they're soldered directly into the PCB, so that holds the whole thing all together, and it's easy to put it together and take it apart. It's much easier to get at. But this thing, literally, I don't know. This is one of those, I said it was an appetizer. Somebody needs to go in and find out, like, where did this come from? Was this actually used in military technology? Was this actually a standard for literally, not that they were putting synthesizers in tanks. That'd be a great movie, actually. You know, going out to the Sinai, you know. But anyway, this was a very early design, and obviously it's what he did, and we don't do it that way anymore. The other thing is the wiring loom that I don't know whether they were talking about it downstairs. The system is not really a fully modular system in the way they are now. Now every module is, when you have a module, you just connect it with the front panel. This one actually had this whole thing going on in the back, and it's very confusing. And it took Iran and Eyal quite some time to work it. Tamir as well, and then quite some time to figure it out. I mentioned this earlier. I don't know. There's a old capacitor factory in West Adams, Massachusetts. It used to be a Sprague factory. It's now a modern art facility. It's a huge thing. I don't know whether any of those capacitors actually made it into the Moog. I suspect they probably did. But the supply chain was very short. The whole thing, I think, was probably made within a few hundred miles of Trumansburg, New York, as opposed to now when things are shipped from factories in Singapore and Vietnam and China and assembled here and there and hither and yon. One of my other passions is the way the shipping container has transformed the world. It did exist. The Sealand Corporation existed in the 60s, but it hadn't yet eaten the universe. So another one where you can look at. I'll skip over this unless are there any enthusiasts in supply chain here who would like to hear more about? Yeah, you got to know your audience. That's what they say. You always know your audience. Okay. Any business students? Any people with their own companies? Okay, we got one. Okay.
I have 2 AliExpress packages in my car.
Okay. All right. Okay. So we have here this one I'll do a little tiny bit on. The instrument was an amazing instrument. It was a historical instrument. But it was a failure as a commercial instrument. It did not succeed. Already by 1969, the very year that the Moog that we have here in Jerusalem was built, the company was already in trouble. There just weren't that many people or organizations that could really afford to spend many thousands of dollars on this brand new and somewhat understood musical instrument. And the Mini Moog and the Moogerfoogers and the Eurorack was all years or decades in the future. So there was a company called Musonics that actually also was trying to build synthesizers. They'd hired somebody who had worked at Moog, realized that it was in trouble, and they actually purchased the company from Bob. It was at that time called RA Moog. They changed it to Moog Music, and the Mini Moog was introduced right around that same time, about 1970. And at that time, it was sold to Norlin, and it's sort of confusing what Norlin was. Norlin was actually got its start making in an Ecuadorian company in the beer and the cement business. Beer and cement. The beer is still apparently available. The beer subsidiary, after various other things, is now part of SAB Miller, and apparently is one of the more successful businesses. Ecuadorians are still drinking beer, it turns out, and using cement. But the business story is fascinating because here's the point where Fidel Castro enters the room. In 1959, the Cuban Revolution happened, and the management of this Ecuadorian beer and cement company were like, we have to do something to reduce the political risk of being being a solely Ecuadorian company. So they decided to expand into electronics and buy some American subsidiaries. And then one of the companies they bought was the Chicago Musical Instrument Company, They at one point owned Gibson guitars. They owned Lowry organs. They owned so they made some band instruments, some woodwinds, and so on. And that was the division that bought Moog, or bought Moog Company, which had been Musonics in about 1970 or 71. So there's a whole other story about what happened in Norlin. It was actually in the 80s. There was a hostile takeover. They actually sold off the beer and the cement, and the whole thing eventually went bankrupt. I don't know. Another thing I found interesting is one of the ways you can protect your company from a hostile takeover is by having ESOP, or employee stock options. And I don't know whether it's as a result of the trauma from having seen what happened in Norlin, but the current Moog Music Company, which Bob eventually got his name back. After he left Norlin, he had to found a company called Big Briar because he no longer owned his own name, which is kind of an interesting thing that can happen to you. But the new Moog Music Company is an employee-owned company, so it's in many ways it's invulnerable to the sort of hostile takeover that destroyed Norlin. And I don't know if maybe there's somewhere there's an interview of Bob talking about that. So why did it fail? There again, I mentioned that it was a limited market. I also mentioned there were certain technical flaws with the product, and ARP, which was another East Coast, literally an East Coast company. It was based in Massachusetts, and it also had, it sort of made it was even more East than Moog because it took all the things that you would want if you were doing that sort of precise, and pardon me if I didn't fully understand, again, my Hebrew is not that great. I think I remember hearing this stuff other places though, maybe. But the very precise, stable oscillators that you didn't have to retune all the time. And they also came out with so they had the ARP 2500, which I have to give a shout out to because that was the instrument that I sort of fell in love with electronic music at Washington University, which also is part of the reason why I'm here, but that's a whole other story. But
there's one in Jerusalem.
There is one in Jerusalem. Yeah, I thank you for reminding me of that. One day I want to give, I don't have to give a talk. I don't need to give a talk, but I'd love for there to be a presentation like this where that 2500 is put out where people can see it again. Because the 2500 it deserves its own conversation, it's a magnificent instrument in its own right. But they also came out with the 2600, which, like the Mini Moog, was a much smaller instrument, and which actually enabled them. At one point in the 70s, ARP had 40% or more of the synthesizer market. Now they also eventually were wiped out in the 80s because Korg and Roland and so on. And I think I mentioned the temperature compensation. Also, Alan R. Perlman had worked at NASA, and he had actually built an op-amp company, so he really understood some of the things. And also the technology was advancing at that point where you could actually get op-amps that would work, although I won't tell you my whole op-amp story, because that's too exciting.
So the ARP is op-amp based resistors?
That's actually a question. There are more op-amps in it, although actually in the 2500, there are not. The 2600 is full of op-amps. But now you've asked, now I have to tell my story. The op-amp that he wanted to use was the Teledyne op-amp, which had better characteristics than the one he ended up using, but it was prone to lockup. But if you take an ARP 2500 or 2600 model and you put in the TL72, it sounds amazing. And I don't know whether that's what he really wanted to do, was to have a better op-amp, because I have one at home. The power supply is broken at the moment, but it's incredible. I'm on another slide. I'm going to skip over this because Tomer went over this. We didn't coordinate, but I mean, this is like one of the seminal albums, and there's a ton of stuff, but unfortunately, some of it's kind of painful to listen to now. If you listen to some of the, somebody did an astrological album. Who knows? Maybe some people here like it. I won't say anything bad about it.
More Garson's one?
I'm sorry?
Zodiac Cosmic Sounds?
Yeah.
Sounds like great.
Okay, all right, sorry. Like I said, I won't say anything. Okay.
You found something.
Oh, yeah. Well, it's always good to pick your audience a little bit, right? What Kafka said, if you should always read books that bite and sting you, books that please us, we could as easily write ourselves. So the same thing with lectures. You should always go to a lecture that pisses you off a little bit. Okay, this is my notion that maybe it's still relevant. I think that's a quote from, well, I see there's still at least one musicology professor, so I think that was Stravinsky who said that. A lot of great music left to be written in C major. Schoenberg, sorry. One of those S guys, sorry. I'm not the professor.
East Coast, West Coast.
East Coast, West Coast, anyway. There's also, I think, a lot of great music can still be made with some detuned sawtooths and a low-pass filter. I mean, it's not it's not like expired. I mean, it's not past its sell-by date. And it's still, as you can see, I'm not quite as sure about the 3-bank 8-step sequencer. That's a little bit more limited of a technological piece, but you can do something with it too, perhaps. Oh, here's the bonus round. This is for any philosophers in the crowd. So I put up a picture of the Switched on Bach album, but that was recorded with a different instrument, right? So is a Moog Modular, like, is that a category? Is that an object? Is that, how do you think about that in terms of, these are exemplars? Like I said, some repairs did have to be made. We've had to replace at least one of the capacitors. Is this eventually going to be the Moog of Theseus, like the ship of Theseus? As you replace it and replace it and replace it, does it stay the same thing? Fortunately, it seems like a lot of the stuff is still, even after 50 odd years, is still pretty stable. Anyway, you can skip that one. I was being a little cheeky there, but is there an ideal Moog? But if you think about what is the ideal Moog sound, and each one of them is there, if we now take this, when I recorded it, I remember using tape, and I was one of those people, I hated it. You have the razor blades and cutting and splicing. It's a nightmare, whereas you can just throw it into Logic, and then everything is beautiful, and you're hearing just the instrument. You're not hearing all the tape and all this other nonsense, but is the other nonsense part of it, or is that something separate from it? For those of you who think the tape is important, I won't tell you what I think. Okay. And finally, it's just been a source of joy for me to be able to spend some time with it, and especially not the instrument is one thing, but the people who are in this room and the people who've helped make this thing possible and bring me here. So, Eyal, Amir, Tomi, Iran, Roni, and Asaf. I think maybe he might have guessed that I was going to say something about him, but I embarrass him. And I guess I'll embarrass Yossi slightly because. When we first found this thing in the closet, I remember looking at it and saying, "Look at this thing! This is amazing." And Yossi said, "Yeah, this would make a great display." And I said, "Display? we have to make this thing work again. We have to be able to listen to it." And so I think it was at that moment maybe that was the actual genesis of this whole project. So thank you all.